Good morning, good afternoon, and good evening, everyone. Welcome to the webinar. My name is Ethan, and I'll be hosting the call. Today, as you all probably already know, we, NXP, have collaborated with our partners over at Crank Software to tell you how you can easily create brilliant graphics on our NXP microcontrollers using Crank's Storyboard software. To kick off the call, I do want to introduce our speakers. To start, we'll have Shelby Unger. She is one of NXP's MCUXpresso product marketers. And following Shelby will be Scott Snyder, who is the product marketing manager over at Crank Software. And then we'll also have Nick Schultz from Crank, who is a field applications engineer. So those will be our speakers for today, and we're all excited to have you on. But before I hand it off to Shelby, I do have a quick points. On the right-hand side of the webinar tool, you'll notice a questions toolbar. Throughout the webinar, you are more than welcome to submit any questions there. And then at the end of the webinar, we'll have time for Q&A where we can go through the questions that you have asked. In a few seconds, I will be sending a link to the slides that we posted on the NXP community. And we will also be recording this webinar, so once this is done, we'll be uploading it to the NXP web, and that recording will be out there. So for any reason you need to refer back to the webinar or the information, you can always do that. And you should expect a follow-up email from us when that's ready. So that's all for me, but with that being said, I will hand it off to Shelby.
Great, thank you, Ethan. Hello, everyone, and thank you for joining today's webinar. So in the interest of time, I'll just jump right into it, just give you a brief introduction to our i.MX RT product family and MCUXpresso. So growing demand for enhanced user experience has really driven the growth of both MCUs and applications processors, but a lot of use cases have emerged where neither one perfectly addresses the needs of the situation. i.MX RT crossover processors were really the first solution that truly bridged the gap between MCUs and applications processors that really allowed embedded designers to easily scale between the two. They're truly designed to support the next generation of IoT applications with a high level of integration and security that's still balanced with MCU level usability. So here's a look at our current i.MX RT portfolio. So currently Storyboard supports all the devices that are outlined in that dark blue. So the RT 1050, 1060, 1064, and then our upcoming product, the RT 1170. And so for the live demo today, Nick will be using an i.MX RT 1060 evaluation kit. And this device is really well suited for embedded graphics applications for the following reasons. So first, it supports high performance real-time processing. It can operate at a core speed of up to 600 megahertz and has very fast responsiveness with an interrupt latency as low as 20 nanoseconds. And then second, the i.MX RT 1060 supports product designs that include advanced multimedia for graphical user interfaces. It features an enhanced LCD interface, as well as the pixel processing pipeline 2D graphics acceleration engine, which supports functions such as color scaling, overlay with alpha blending, image rotation, and color space conversions. And all these features are also included on the RT 1050 and 1064. So all of the i.MX RT devices and general purpose MCUs at NXP are supported by our MCUXpresso ecosystem, which some of you are probably already familiar with. So at the heart of this ecosystem are the core technologies that NXP provides as a cohesive set of software and tools for designing with NXP MCUs. This includes the integrated development environment, software development kit, config tools, and the new secure provisioning tools. And these software and tools have all been specifically designed to work together in a very efficient and streamlined manner. So the core MCUXpresso technologies are further enhanced by the enabling software and tools technologies that we provide at NXP and are also provided by our partners. So this includes anything from runtime software and middleware, partner IDEs such as IAR and Kyle, debug probes, and various development boards that work really seamlessly with the core technologies and help speed up the development process even further for you guys and allow you to focus more on differentiation. So now to dive a little further into the SDK. So the MCUXpresso SDK provides the software framework and drivers that are key to an efficient development experience. These include optional support for FreeRTOS and various integrated stacks and middleware. It also includes reference software that comes in the form of different driver, middleware, and FreeRTOS usage demos, as well as various application demos. All of the software is BSD licensed, Black Duck scanned, and free to use. And you can use it with peace of mind, just being confident in the fact that it's been coded against industry quality standards. One of the major benefits of the MCUXpresso SDK is the enabling software technologies. These are the integrated stacks and middleware that we provide for a variety of applications, including wired and wireless connectivity, graphics, motor control, and many more. Some of these are developed in-house at NXP, and others are developed by third parties, but they're all provided for free and just give you a head start in developing your application. Something that's new with this release, which is kind of the focus of what we're talking about today, is that we've taken ease of use to a whole new level just by taking the strategy of focusing on some key technologies from strategic partners, where we're not providing the software from in-house, but we're enabling you to very easily access an evaluation version and fully evaluate it before making a buy decision. So once you do that, it's really easy to keep moving forward in your development flow without having to redo anything in your project, since the software is already tied in with the rest of our SDK. So we've really made it a very streamlined approach. So with the most recent release of the MCUXpresso SDK, Crank Storyboard is actually now one of these enabling software technologies that comes fully integrated with the MCUXpresso SDK. We currently have support for i.MX RT1050 and RT1060, and this is something that we're really excited about. It's never really been done before, and it'll make it a lot easier for you to go in and evaluate this software in conjunction with our MCUXpresso ecosystem, as well as your NXP device. So when you build and download your custom SDK for either of these parts, using the online SDK builder, you now have the option to include Storyboard as one of your optional software components. And when you do this, you'll have access to several fully functional examples that you can immediately program onto your board to get a feel for the entire solution. Crank also offers a 30-day free trial of Storyboard, so if you want to go beyond these examples that are included in the SDK, you have the option to do so. And this really makes upgrading to a full-featured paid version of Storyboard quite seamless, and you'll really be able to see how streamlined this whole process is during the next demo in just a little bit. So if you want to learn more about MCUXpresso software and tools, here's some links to additional resources. These will all be in the slides that are posted on the MCUXpresso community. And with that, I'll hand it off to Scott to tell you a little bit more about Crank Software Storyboard.
Perfect. Thanks, Shelby. I think we have a quick poll coming up. Ethan, if you just get that out. Okay, so I just wanted to just kind of gauge everybody that's on this call. This is, have you ever used Crank Software Storyboard UI development tool in the past? Is it yes or no, or perhaps no? This is the first time I've ever heard of about Crank and about Storyboard. So just take a moment and use the poll, and we'll just kind of jump into things in a second.
So we'll leave it open for maybe 3 more seconds. And then Scott, I will hand it off to you.
Perfect, thanks. All right. Perfect. So do we have the results of those polls?
Yes, we do. So it looks like we had 15% of people say yes, they've tried Crank software. 53% said no, and then 32% said this is the first time that they've heard about Crank.
Perfect, and that is potentially one of the things or the ways I thought that poll might go. But there's a good chance that even if you have not heard of Crank software before this presentation, I can guarantee that you probably have interacted with a product that is running one of the UIs that were built or developed using our software. So definitely, as you can see on the screen, many different verticals and industries have come to Crank software to utilize our UI development tool. So, just to kind of give you quickly, just to kind of, understanding of who Crank software is. Crank software is a software and services-based company that is headquartered in Canada. Our leadership team has an extensive background in embedded graphics systems with over 20 years of experience in the embedded device world. We have supported large Fortune 500 companies and even small organizations. We have this large global customer footprint and have hundreds of millions of devices in the field today running a UI built using Storyboard. And of course, we offer our customers access to a global distribution partnership network, really providing localized support across different regions. So just to kind of let you know as well, like I said, we are a services-based company. Well, we do have professional services where we can help you develop a UI prototype to really kind of maybe help advance the project to get funding. We can even build the UI for you for the device as well, based upon maybe UX design or just working with your project team to understanding what you're looking to achieve. As well, we can take the UI and really kind of like optimize it, performance optimization of it, and much more. So we have a wealth of different services that, if you were stuck or if you're a smaller organization, you don't know where to begin, definitely don't be shy to reach out to Crank Software to find out how we can assist you. So let's just kind of jump into talking about Storyboard and developing UIs in today's market. Definitely when it comes to developing UIs for today's embedded products, things have become increasingly more challenging. Definitely user expectations have been elevated. Today, consumers expect an intuitive and modern touch experience, not only for the physical hardware, but the quality and smoothness and the experience of that UI that it presents. And this is all because of every day we walk around with a touch-based screen in our hands, which provides this rich graphical user smooth experience. And so anytime they walk up to any device with a touch screen, they expect a similar type of experience. Definitely the user experience has quickly become a defining part of today's products, with its UIs being one of the main factors that products are being measured on, and what often drives the value consumers see of the product and often drives their purchasing decisions. Definitely also integrating evolutions in technology doesn't only mean making hardware decisions anymore, but also how will they be incorporated into the user interface. And of course, anytime time is lost or resources are wasted, or maybe coding changes need to occur, this all creates delays in getting the product to market on time and sometimes on budget. It goes without saying that given enough time and resources, the ability to develop a product that blows, the competition out of the water and exceeds all consumer expectations is possible. But when it comes to projects, there's never enough time and resources a given. And this is where really Storyboard comes into play, because Storyboard really was designed to help remove the barriers that are typically associated with UI design and development. So it was based upon over 2 decades of experience in designing and implementing embedded UI solutions for a broad range of industries. So the founders of Crank Software, what they did is they set out to build a solution that could really remove the inefficiencies that frustrated them and their colleagues when it came to developing UIs for embedded devices. So what they did is they decoupled the front-end UI from the back-end logic, really enabling the designer and the developer to work in this collaborative parallel workflow while they build the app. Therefore, really making it possible to get started early on developing or creating the UI, really making it easier to embrace design iterations that, it's not a matter of if they're going to occur, it's a matter of when they're going to occur. So really making it easier to embrace that. And of course, helping reduce the overall complexity of developing UIs for an ever-evolving embedded hardware, or maybe even product lines you have within your organization. So in other words, what Storyboard really does is it helps project teams develop UIs for embedded products more efficiently, making it possible for them to get to market faster. And, what are some of the ways that it does that? Well, you know what? UI development can begin within familiar UI design tools such as Photoshop and Sketch, and then when ready, be imported into Storyboard, which then creates the building blocks of the UI. And of course, from there, the UI can be brought to life using Storyboard's integrated animation tools, really allowing you to create, edit, and review animations all directly within the Storyboard workflow. Of course, once UI development begins, designers and developers can continue working in that collaborative workflow environment that I talked about, really helping remove the pain and the struggle associated with iterations that occur within embedded projects. So, when design changes need to occur, they can occur again in Photoshop, and those files be re-imported into Storyboard without having to create an entirely new application or overwriting prior development efforts. And then we have a tool, which is a unique tool that no one else offers, called Graphical Compare and Merge, which allows the teams to remain in control of these iterations by being able to, take a look at what was there before, what has been imported, and selectively choose which changes you want to import into the UI, really making a more efficient, organized workflow, in particular when you have multiple users across a network doing the development. And then, of course, Storyboard was created to be platform agnostic so that customers can easily de-risk their projects by introducing this framework that easily supports technology and design changes at any point during the development cycle, really allowing for overall UI flexibility, such as scalability from maybe an MCU to MPU, or from an MPU down to an MCU, portability, so moving as maybe you move over to a different microprocessor, and, maybe the OS needs to change as well. So really supporting that, and reusability, allowing you to take that UI and maybe port it across different projects to really provide that more consistent look, touch, and feel for a product line that you may have from low end to high end. So really providing overall flexibility for your organization. So I just want to kind of pause and kind of talk to you about, one of the customers that we've helped achieve this. So definitely, this customer wanted to introduce their next gen beverage dispenser with new technologies and UI changes based upon consumer feedback. However, they had existing products that were in the field that were using older, lower powered embedded devices. And so they didn't really want to disrupt those products in the field. They wanted to, take these changes and be able to embrace it across the new and the old. They were using a different development tool and they found that they weren't able to achieve this. However, so when they came to Crank Software, we worked with them, and we were able to show them how, our optimized footprint for the MCU marketplace, such as say the 1060, could easily be, ported into that, as well as maybe these higher end, maybe different processes that they were using for the new general, for the new beverage dispensers. So definitely what we were able to do was to provide them with this exceptional UI experience that easily could be utilized across the old and the new, without disrupting the devices in the field, saving them significant time and, of course, money. So really when it comes down to it, what makes Storyboard different is that we are not a code generation framework. So what does that mean? That means it really provides a lower barrier for entry for your organization, because now you don't have to worry about knowing a particular coding framework or heavy extensive C++ coding. And what it easily allows is for those iterations to occur, which does not tear down the code. So like I said, that the decoupling of the front-end UI from the back-end logic, but we're having a well-defined data model and event API that connects the two in between, really provides that clean separation between UI development and hardware deployment, really making the UIs to be more resilient to design changes. And then, of course, we work with partners like NXP to really do some extensive development and testing to really make sure that our storyboard engines that are optimized for the target platforms which you can go on, without having to worry about the engineer back in your project having to compile and doing all that heavy lifting. We've done it all for you. And so really allowing you to take advantage of specific board features, maybe such as proprietary graphics libraries, or maybe unique kind of 2D, 3D kind of hardware accelerations that have been introduced, and of course, memory management functions. So, this is something that we take great pride in, from starting with a Photoshop design file and importing that into Storyboard. When you go and you're using the evaluation period, you can really get the basics of that UI going in 10 minutes or under. Nick is going to basically walk you through multiple steps, so it'll be a little bit longer than 10 minutes from the SDK process all the way down. But it's something we take great pride in, and that's because of the fact that we are that more lightweight, and we're not that coding framework, which really allows you to kind of, like I said, once you start importing from Photoshop, it becomes the building blocks, and some of that information about the structure becomes the base layer for the coding to provide some UI elements on it. And at that state, I'm going to pause. I'm going to kind of pass things over to Nick, and I'm going to let him show you the magic of taking something from the SDK all the way into Storyboard.
All right. Well, thank you so much for the great introduction and early bit of the presentation, Scott and Shelby. So from here, I'm going to take you guys through the process of getting up and ready on the RT1060. So you should be able to see my screen here. And first thing I just want to quickly call out is, as Shelby referenced in her slides, there's two dependencies that we're working with here. The first being the MCUXpresso IDE. And this is a tooling solution to help you build up your project so you can get ready to flash the board. So you'll want to download that from the NXP website here. So if you were to search NXP MCUXpresso, that should get you here. The nice thing is, just like Storyboard, it's supported on Mac, Windows, and Linux. So no matter what your development environment, you should be able to get ready to roll. And the second bit is, we are now integrated in the SDK for the RT1050, the RT1060, and the RT1064. So to do that, the next bit is you need to go into the MCUXpresso SDK builder and build your SDK package. And you'll need an NXP account for that. But what that looks like is, once you've logged in, you'll be greeted in this dashboard. You can see here I've already built up a couple configurations. But you'll just need to pick the dependencies and middleware pieces that you want to play with. And one of those being Crank Software. So if you select the Select Board option on the left, you'll be prompted with the ability to select a board, kit, or processor. So if I were to start typing 1060 in here, you'll see here we have the EDK RT1060. And once you've selected your board, select Build MCUXpresso SDK. And this will take you to a page where you need to pick some of the components that you're looking to grab here. The basic building blocks, so the CMSys DSP, AWS IoT are already selected. We'll need a couple pieces. The first one is the Amazon FreeRTOS piece. As you saw, our demos are based on top of FreeRTOS. And from there, you'll want to select the Crank Storyboard GUI middleware. After you've done that, select Build SDK. It'll generate an archive for you, and then once the archive is complete, it'll prompt you to download. For the sake of expediency, I've already done that, so we're going to switch over to MCUXpresso. And when you have your archive downloaded, all you need to do is drag it into this section in the MCUXpresso environment. So that's the Installed SDKs tab. And you can download multiple variants. Maybe you're prototyping a 1050 or a 1060, so you could have multiple sitting side by side. But all you do is you download it, drag it in here, and then if you want to get started, you select Import SDK Example. You can do it from the Quick Start panel in the bottom left or under the File menu. Select Import, select your board. From there, hit Next. And then there is a section for Crank Storyboard examples, alongside with many other examples of how to get different components up and running on your development board. Expand that. And in this case, I'll start off with the Crank Software Hello World example. So this is a minimal product configured using our Storyboard Lite configuration. And this is really a configuration based for small memory footprint and resource constrained devices. So if you think of the evaluation kit for the 1060, you know there's some external RAM and flash available. Maybe you're not running with that configuration and you're only running with the internal flash and RAM on the 1060 chip. So these type of projects with the Storyboard Lite configuration are a great optimized solution for that. And you'll see in my Project Explorer here, I have that Hello World project here. Inside, a couple things to point out: the Crank Software directory, that's where our embedded runtime libraries are located. And the source directory shows where all of the integration for the project lives. So once you start doing a little bit more, and what I'll be showing you shortly, you'll be interacting with this directory. But as a starting point, if you just want to get up and running, all you need to do is build, and I always like to do a clean, but you can build and then flash this project. Build. You'll see some output in your console. And once that's complete, we can debug and flash it over the CMSys DAP connection. And again, pretty easy process. We're ready to go out of the gate. And once this is done, I'll switch on my webcam to show you my evaluation board that we have here running the sample. Now that we've built, you can also see some output showing different regions of memory usage and how many bytes and configurations that we've done. So again, there's a lot of tooling and diagnostics available to help you fine-tune your application. The next step, if you want to build it, is you can select this debugging icon in the toolbar, as well as in the Quick Start menu, or for right-clicking on the project. Select that. It's going to be looking for the debug probes. Okay. And it's going to start going down and flashing to the board. And you're going to get some output information in the console, where it's going to be showing you the percentage it's writing in different blocks here in 1 meg increments. But also in the bottom left, you get an overall process of the flash process. This is directly related to how large of a project and application you're flashing down. So obviously, the larger the application, the longer this will take over the serial debug connector. But it's still not too bad. But in the meantime, while that's working away, I'm going to quickly cut over to Photoshop, and I'm going to set the stage for the next stage of our demo. So we have a design here that was created by one of our in-house designers. It's for a smart home controller thermostat panel. So you can see here on the main screen, we've got a pop-out menu with some different options, a thermostat screen for increasing, decreasing temperature, some tab navigation at the bottom. So here you've got a weather screen, settings screen, security, and other different content. So this was all laid out in their design tool, in this case Photoshop. As Scott mentioned, we can also support Sketch, and we can just take this file directly and import it into our tool. The nice thing about this is there's some naming conventions that you can use that really help you expedite development. So as you're going through and iterating and developing, your designers can lay out content exactly as they might see it, and it'll translate seamlessly into Storyboard. So I'll go ahead and close this. And it looks like our flashing process is complete. So the first thing it does is it stops on the first call in the main function, and this is where I'm going to enable my webcam. See what I see. There we go. So that's a view of the RT1060 EVK. And then if I hit the resume button, you can see now we're running our Hello World application. So it's a pretty stripped down application. Just gives some information for downloading the storyboard evaluation, shows some animations. It doesn't really do anything apart from that. So I suspect pretty quickly you'll realize that you want to do something a little bit more exciting than what you see here. We also have a coffee application for a coffee maker, which is a little bit more complex in the SDK. So you could download and import that as well. Or you might want to create your own project. So if we think of the PSD file I showed you, let's take that and create a sample application that we can flash onto the 1060 board. I'll just quickly terminate the debug sessions. And I did mention earlier that the projects integrated with the SDK are based on a light configuration. We offer a larger subset of functionality, so the ability to use Lua scripting in your UI, or more animated screen transitions and things like that. So if you are looking to go down there and perhaps you have some more memory available to you in your design, you can upgrade your project into our real-time executive configuration. And that is something that isn't very complex, but for the expediency of time, I'm just simply going to switch to a pre-configured one. But we have all the instructions available online, so you can see how you go and upgrade this Hello World project. But in my case, I've already got it into the workspace here. And it looks pretty much the same. The only difference is that the runtime has a larger subset of libraries and plugins available to it. So you can see here, Lua, and some other screen transitions there. But we go back over and we switch over to Storyboard. This is where you get to start playing around in the tool and creating your UI. So if it's the first time you've ever downloaded the tool, you'll be greeted with their welcome screen. There are links to tutorials, documentation, our support portal. So really a great way to get started. And from there, you can close this out. And in our case, we want to create a new project from a Photoshop file. A couple different ways you can do that. I'm going to select the icon in the toolbar at the top. I'm going to open up a wizard. I'm just going to browse to the Photoshop file that I was using in Photoshop right here. Select open. We're going to leave everything as default. Basically, there's a few different options here. So if you wanted to kick off a new project, or maybe you're already building a project and assets are coming in piecemeal from the design team, you could always select a different option here. So maybe you've got the first main screen, and then they're coming in with the weather and security panel after the fact. We support a wide range of process, and what I hope you'll take away from this is that the workflow in this tool is dramatically different. We really do want you to iterate and test and develop when building up your UI and deploying it to hardware. When I hit finish, we're reading and parsing the Photoshop file. The tool has sliced up all the image assets for us. And you can see here we have all of our screens laid out as we saw them in the tool. The model hierarchy also follows the architecture that was laid out in the Photoshop file. So depending on some of the naming conventions used, you'll see here we have our menu layer that's right there. So we can hide and toggle that, as well as other screens that we can create transitions to. The first thing I might want to do is create an animation to pop out this side menu and trigger it from that hamburger button. So without going into too many details, Storyboard offers you a wide range of options when building up content. You can manually create these in our timeline editor in the tool. So if anybody's got a design group that's familiar with, date myself a little bit now by saying Flash or After Effects or some of the newer animation suite, they should be right at home here. But we can also bootstrap this a little bit more, and we have an option to simply record changes that are happening in our model editor. If I select this icon, you can see now we've got this red bar around our main view. And anything that I select and manipulate, these changes are going to be recorded and turned into steps or frames, if you will. And you can see down here we've got this recording frame 1. So we're going to build up a series of these frames and changes. And thinking of an animation, it's simply a change of a property over time. So the first thing I might want to do is start off with this menu screen offset. And actually what I'll do before that is I'll just quickly bail out about this. I want to do something a little different. So we're going to start by offsetting this menu, right? Since we want it to be hidden by default and then slide in. So the first thing I'll do is slide that over roughly 150 pixels off to the side. Save that. And then we'll go back into our recording animation where I was before. So when the user presses the hamburger button, we're going to slide from -150 back to 0. And then we can close this off here. You can have as many steps as you wanted. So maybe you were doing a multi-piece animation where it's slid in a little bit slow and then picked up velocity. You could also create snapshots and create multiple steps as you're going. In this case, I'll simply give it a name here. So I'll say menu open. Hit OK. And then you can see that was translated into a brief animation in our timeline. Again, if you wanted to get complex, you could have multiple steps. But in this case, we're simply sliding something out. I can preview how that looks. If I select that, you can see here we have this little preview panel where I can walk through the animation. And that's okay, but if you're familiar at all with animations, you'll notice that the motion curve or the easing rate, as it's so-called, is linear. So it doesn't really have that nice fluid feel. So I can go and actually manipulate that. In this case, I'll select something where it's more of an ease in. And you could even create your own custom curves here by adjusting this. Save that. And then you can choose if you want this to be a little bit longer or slower. So I'll just go ahead and increase this a little bit, 750. We can preview that. All right. Maybe I want to go back down a little bit. And you can get as finicky as you want with that, but for now, I think that's okay. And then we'll break out of this. So the user presses this button, we trigger the animation out, and then we also need a way to close that. So we have a handy function here where we can create the inverse of an animation. So I'll right click and say add reversed animation. Leave the name default just so we know what's going on there, or you could call it something else. Closed might make sense in this case. Okay, and now you can see we have these two animations. So what we have to do now is we have to hook these up to our application. In Storyboard, everything happens with a series of what we call events. Without an event, nothing is happening on your display. And this is really a key important takeaway because we are completely event-driven, and on systems like the RT series that are these crossover boards with MCUs, you might want to be diligent about your CPU cycles and resources. So if your screen is idle, we're not rendering taking up CPU. So until something tells us to react, we aren't using any of your resources. So you can have very, very tailored, efficient applications And you can have very complex user interfaces running on these platforms, which result in lowering your bill of sales or bill of materials costs. So kicking all that off, we're going to trigger an event. So if we select our button right here, we can right-click, say add an action. So this event, which is going to be a user input, so a touch, triggers an action, which in this case, you can see in the list of actions is an animation. And we select our menu open, finish. And then once the menu's open, we need a way to close it. And there's a button in our menu layer. And I know it's off screen right now, but I'll use the top button. And again, we're going to do the same step. So touch, animation, close, finish. Once you're happy with something that you've built up, you can actually simulate your application in Storyboard. And this is the same embedded engine that's going to be running on the RT board, or maybe you're looking at a multi-processor line product. So perhaps you're looking at an i.MX 6 series, an i.MX 7, or even one of the i.MX 8s. You can build one application in this tool and run it on multiple different platforms. So when I run this, we know the same code is happening, the same event processing, and we have a very high degree of confidence in what we're building. So this really helps reduce the iteration cycle. If I hit our menu button, you can see it slides out there, and then our top button here closes it off. We also have some pre-defined events for these plus and minus buttons. They were set up in Photoshop, so if you follow the right naming conventions, you can actually bootstrap buttons with their active inactive states. So part of why we wanted to upgrade to the real-time executive platform is because we can use things like Lua. So this is a great way to show you how you can go about using the Lua scripting language. So if you were to think this up button increases the temperature, we can go ahead and quickly do that. This text field, as it is simply text. It's static. It's nothing dynamic about it. So we can bind what's called a variable. And similar to how animations were changing properties over time, all properties can have a variable associated with them. So in our menu open, we change the X value. But in this case, maybe we want to manipulate text. So whenever you see these angle brackets with a plus, you can select that, create a new variable. I'll call it temperature. And then this is something that when you update it, whether it be in scripts or through data changes in animations, the engine will know to redraw on the display. Okay. And if we were to look at our variables panel, we can see temperature is available right there. And I'm going to go ahead and I'm going to copy the path to this variable. So we want to manipulate that in script. If I right-click on this button, say add an action. We can use a touch event again. And scrolling down our list, a Lua script callback. I'll give it a name, callback for CD, temp up, and hit finish. If we hit edit here, this will pre-create the function stub for us, and this is a script file in our project directory, which I'll show you shortly. In the case of a real product, this press event would likely fire an event off to some machine controller to say, okay, increase the temperature in the house. And then when the temperature sensor on the device detects an increase, it would feed that data back into the UI. We don't have a real furnace and home hookup right now, so I'm just going to short trip this one by creating a temporary value in Lua to hold this. 20 right there. And then in our callback, I'm going to simply increase that. So again, some pretty basic scripting right here. Once we have this, we can push this back into the UI, and that's where that variable that I created earlier. So if you remember the thermostat layer, temperature control, called temperature. Variable right here. This is where that's important. Since we've created that binding, I can manipulate it in script. And from there, I can increase that value. So we've increased it. The last thing I need to do is push that back in. So we have a function for setting values. That takes a key value pair. You can imagine the key is going to be the path to the variable. the value is our new temperature value. The last thing I want to do is I want to concatenate the little degree symbol on there just for presentation purposes. And Lua is not a statically typed language, so it handles that for you. There you go. So you can see there, we're updating this value with our new temperature value, and this will convert it into a string to push back in. If we save everything and simulate again, we still have our animation, but now we also have the ability to increment the temperature. So that's awesome. The last thing that we want to do is we want to show you how to push that back onto the board. And while I've been talking here, you're likely wondering when we're jumping back into the MCUXpresso world. We're going to do that shortly. We need to export this into something that the FreeRTOS project can leverage. So we have the ability to create export configurations, and this is how we can support a wide variety of different platforms. In this case, the default one is considering you're likely running a Linux system. So I'll go ahead and create a new one. I'll call it 1060. I'll base it off of the default configuration that already exists. I'll say OK. And from here, we get to select a couple different parameters. The important differentiation is everything's running off of Flash on this platform. It's not a traditional file system like you'd see in a Linux or QNX system. So I'm going to select the virtual file system. And the other thing is you can choose if you want to have bitmap or TTF font rendering. The light projects that you saw in the SDK were using bitmap font rendering, again, reducing RAM usage. In our case, since we're configuring this for the real-time executive system, we're going to use the free type font engine that can support TTFs. And this is really good for building up rich internationalized products with different character and font sets. The last thing is how do we want to store our assets? So that's images. In this case, you could store them natively and decode them into RAM, but more RAM means higher bill of materials costs, so we might as well store those directly in Flash and render them from Flash. And you can see here as I've ticked that, so we've got the application metrics on the right are starting to update. You're seeing RAM has now been offset into Flash storage. The last thing is we want to start the image alignment, and that's something that's just relative to the image bit depth that we're storing. Save, and from there, we can go and export our application. One thing you might want to do, since I mentioned the flashing process is directly related to all the image assets you're sending down, you can run a quick cleanup since some assets may have come in from your design file that you're not actively using. So in this case, I'll hit that, and this is just going to clean up any unused image assets. As you see there, we've deleted some of them, and if I open our metrics view again, we've saved a significant amount of resources. So we've gone from about 5 megs of flash down to 1.2. That's going to save you time when flashing to the board as well. The last step is now that we have our configuration, we're going to export this application. And this is where in our export dialog, we select the export type, Storyboard embedded resource header. In this case, if you were exporting for an Android device, you could use the APK. Linux would be the GAP, like that. In our resource export configuration, you can pick the configuration you created, in this case, the 1060 demo I just did. Hit apply and run. That's going to then convert this model file into a header file that can be linked into the project. So that's exporting the layout, any of the animations, the variable bindings and actions into a binary output that you can then link in and build. The project that we have here, the thermostat, is going to have the header file exported to the root of this directory when it's done. But just for your curiosity's sake, if you're wondering where the script file lives, the callbacks.lua, it simply lives there. Same thing with all of our images and font assets as well. So your project can get as complex as you want it. And then again, once you're ready, you can then deploy this down to your hardware. So this is just going through. It's going to take a couple moments more. I'm going to quickly jump back over to MCUXpresso. This is where we'd open up the source directory in our project. We drop our exported header into this directory here. So it would be the SBEngine _ model file. We're going to overwrite that. If ever you chose to give it a different name, that's where you could modify that in the SBEngine task _ PXP. So that include line is down on line 97. So maybe you're testing with a couple different variants. You could then modify that here. You can see here the header file was exported successfully. All we need to do is copy that, jump back over, paste this into our source directory. I'll choose to overwrite it. From there, we simply do, again, what you saw, a clean, and then the debug in Flash. Debugging will also do the build for us. And this is going to go through, build our project, flash it onto the board, and once it's complete, we can interact with it there. So this will take a moment or two, and while that's happening, I'm going to quickly pull up a slide here where basically this is some of the takeaways that, whoops, don't want to do that. Some of the takeaways that we have from what you saw today. Really, the main thing is we really encourage you to play and iterate. So the first steps in that, as I showed you, is download the free NXP MCUXpresso SDK and IDE, as well as, once you've done that, download the Storyboard trial, because from there, you can go ahead and start playing around, developing applications, and then flashing them onto your hardware. So from here, you've got all the power in the world. The Storyboard download is a free 30-day trial. It's not hampered in any way. You can prototype on any of the supported NXP boards, so any range of the i.MX 6 processor, i.MX 7 and 8, as well as the RT series. So that's sort of your getting started. And from there, we've got some questions. I want to just wait until the tooling is done flashing. You can see here we've got right about 14%. It'll take a little bit longer. It's a bigger application. So at this point, how about I open up the floor to some questions, and then when it's ready, I'll switch on my webcam and show you the interaction on the hardware.
Perfect. Okay, just before we jump into the questions, there's one thing I just wanted to kind of focus on that last slide that Nick was talking about there, that we also have within our support center that you can get to from cranksoftware.com, we have a variety of videos that have been turned into knowledge base articles that Nick worked on that really kind of walk you through the steps as to, what you need to do to basically kind of get that SDK and put Crank software into it, to, switching out from maybe the light to RT exec, so you can add on additional plugins to get access to additional capabilities, as well as modifying your actual application. So really giving you a well-rounded tool set to really help you really evaluate Crank software as well as the NXP board. So definitely, we have more than that in a knowledge base article. We have a variety of getting started videos to really kind of help you out there. But it's a great resource for you to go and to learn more about Storyboard and interacting with Storyboard. So I highly recommend, if you haven't visited it, then definitely kind of take a chance, take an opportunity to go there today or at some point over the next week or so to learn a little bit more. And with that being said, I'll pass things over to Ethan for the questions.
Yeah, that sounds great. So we do have several questions, so I'll go ahead and dive right into them. So Nick, this is for you. There's actually two questions on this, so I'll bunch it into one. In what file format do you import from Photoshop? And then there was also a question asking which file is exported from Photoshop.
Sure. So these questions are actually one and the same, because we import the PSD file directly from Photoshop. So if you're looking to bring in assets into Photoshop, then that's really, you know, whatever format Photoshop accepts, it's a rasterized editing tool. If you're coming from maybe vector art from the Illustrator side or XD, you know, Adobe has a couple ways to import content cross-program. And then once it's in your PSD, then we can import that directly and parse that. Our tool is going to convert all the assets into rasterized images. So for rendering performance on these platforms, raster assets are a little bit more performant. So things like JPEGs, PNGs, BMPs, stuff like that. And that's basically it. There's a few, again, I mentioned there's guidelines on how to structure your design file, and we've got a lot of documentation around that. And from there, you know, you can really bootstrap your design. As you saw, I had a full fleshed out design file that was ready to add interaction and iterate on.
Cool. All right, so another question. Our products are distributed globally. Does the Crank framework support multi-language support?
Absolutely. And while this question came up, my Flash process just completed, so I'm just going to quickly turn on the webcam as well, just to show that we have that here. And I'm just going to hit run on this end. So you can see we have the application there. Apologize on the glare. I'll try and fix that. But you can see here now, if I were to press the button, increase the values here. So we were able to flash that down to the board. But in terms of multi-language, we certainly do support that. You noticed when I did the export configurations, and I'll quickly switch back to that in Storyboard. In our export configurations, we had the option for TTF font support. So we render content with the FreeType rendering engine. And with there, you can import TTF or OTF fonts. And those fonts in the project are things that can also have variables assigned to them and swapped out on the fly. So if you look at our text down here, this is using the Roboto Condense font that has a variable assigned to it. So if you had a menu to say, switch to Arabic text or non-Latin character sets, so maybe Cyrillic for Russia, you simply swap out that font, and any text field that's referenced to that will then be updated. So again, these variables are all control points for different elements in your application. It could be fonts, it could also be point size, as you might imagine. Language like German is much more verbose. Maybe you need to reduce the font set and point sizes in some case. So we certainly support multi-language and really internationalization as a broader topic. And we've got customers shipping with multiple languages in different regions as well. And that's sort of a topic all in and of itself, but that's sort of my short and sweet answer for you.
Awesome. So let's go to the next one. How do you connect the UI to real hardware operation and external real-time threads?
Great question. So without going too deep into code over here, the way Storyboard works, as I mentioned a couple times, is everything is completely event-driven. And what you saw me using was touch events. But an event can be anything. An event could be the completion of an animation. It could be something that a timer fires and triggers a behavior, or it could be something that's completely custom that you define. So in the case of our thermostat example, you could have a set of events for temperature update, and this is something coming from an external source. So this event could be injected into the UI, and it has a data payload with it, and then within Lua, or if you wanted to use a C callback, you could grab that data payload and update the UI. We also provide a library called Storyboard IO, which allows for that cross-task or cross-process communication. And Storyboard IO is a platform-agnostic library, and it's a C library. So basically, you use it regardless of your platform, FreeRTOS, Linux, QNX. You'd write the same API calls, and it's very similar to message queues. and that allows you to inject events into the system or receive events from the UI as well. Going back to that thermostat example, it may be that when the user presses the up button, it sends an event to say temperature up, and the machine controller interprets that to increase the house temperature. So that is available to you, and it's something that you could create your own separate task in this project. And if you were to start playing around with this SDK project, you'll notice the Storyboard UI application lives in its own task. It also has tasks for timers to handle driving animations and behavior like that, as well as a task for input handling. So hopefully that answers that question there.
I think so. So we are at the top of the hour. So if you need to leave, you're more than welcome to. But we do have several questions that I think are really good to ask. So if you're okay to stay on, Nick and Scott, then I'd like to ask these right now while we can. Maybe we could do rapid fire.
No worries, and I'll try and be a little more brief. I tend to give a lot of words in my answer.
That's okay. So let me just go through them. So the trend nowadays is for non-rectangular, for example, circular displays. Is that supported?
Certainly, from our point of view, we render to frame buffers, and I know NXP is coming out with a product line of circular displays that have that type of interaction. So we actually have a couple products coming out to market that are circular display based, and we can handle that. It's really no different in our tool. You simply update to a region. In the Storyboard tool, it's still a screen, and you do all your manipulation there.
All right. So how how does Crank communicate with hardware? Does the GREIO still work?
Yes. So that's sort of similar to what I was saying earlier with Storyboard IO. The library, so GREIO, is in fact the same Storyboard IO library. There's just the original engineering name for it sort of stuck around from a binary point of view, but I refer to it as SBIO. So that is in fact the same thing.
Cool. Does Storyboard and MCUXpresso support i.MX RT 1020 EVK and the 1010 series?
At this moment, we don't. However, going forward, assuming that's something that the people managing the roadmap decide to go with, there's no reason we can't. And there's another reason. A lot of customers come to us with custom board and operating system requirements, and we are quite flexible in terms of being able to port our software to it. Really, the main thing is having enough hardware for what you're looking to accomplish. So if you have enough memory for your frame buffers on the display, and that's simply a width times height times color depth operation, and then generally we say a couple 100K of RAM, just conservatively, because we don't know the goal of your application, then we can conceivably run there. But at the moment, we don't directly support that board, but that's something where if you were to contact sales@cranksoftware.com, we'd certainly engage you in the conversation. And from a quick off the cuff, I don't see why there would be an issue running there. And down the line, maybe that's something you'll see coming up in the SDK as a pre-existing application.
All right. Let's see. Does Crank support swipe events?
Yes, we have a plugin for gesture input, so you could do left, right, up, down, or diagonal swipes. You could also then define your own custom gestures if you wanted to do a zigzag type input. So we have a plugin to support that. The real-time executive package has that plugin, and that's what we'll see in this directory here. The light configuration does not have that, and that's simply we stripped out some pieces just for the smaller memory footprints. But yes, we support that.
Great. Is Storyboard dependent on RTOS?
We need some form. I'm not going to say an RTOS, but there's a few pieces that we need. So we could do a more bare metal type solution. We do require the ability to create tasks. We need to be able to synchronize between them, so mutexes, semaphores, things like that. We also need to be able to call malloc and free, so a heap 3 style memory allocation framework, as well as having some support for timers. But generally, those are sort of the high-level pieces. So we've worked with customers that have their own OS abstraction layer, and we've ported to that as well. FreeRTOS is just fairly common, so we use that as a starting point for these samples, but by no means are we limited to that RTOS.
Got it. And I think, Scott, this might be a question for you. Is Storyboard free, or do you have to pay for it?
So yeah, good question. So there is a cost associated with Storyboard. We have 2 different licensing structures. One is for Storyboard as the development tool itself. It uses a standard licensing model that's based upon a per developer kind of standpoint, and it can be used across multiple projects. It's not kind of linked to a single project. The second is that there is a runtime license that is also required, and that is required on each device that the Storyboard created UI is going to be deployed upon. And of course, this is based upon a per product and volume-based licensing model. So definitely, it really depends on it makes it unique for each project that's there, whether it's a limited run or across thousands of devices. So there is a bit of a change with that one. So definitely, when engaged with our sales team, definitely they can kind of sit down and discuss that with you a little bit more and deeper.
All right, and then I think we have one more question. Does Storyboard support ping pong frame buffering in the foreground and the background?
Yeah, so generally that's the approach that we use. So in the demo that I just showed you, there's 2 frame buffers allocated, and again, that's where you're displaying one and updating the other, and then swapping them. And we also leverage the PXT acceleration to help the buffer swap and transfer, so we get a little extra performance out of that. You could configure for a single frame buffer configuration if you wanted. The one difference with that is if you're looking to do full screen blends or fades, things like that, you may not get the effect you're looking for, where to avoid tearing and things like that, you need the second frame buffer.
Okay. I believe that's it for questions. So thanks everyone for joining. Thanks for staying on a little bit past the hour to go through this Q&A. We appreciate your attendance. Scott, Nick, Shelby, I don't know if you have any closing remarks.
Sure, I'll jump in. Just appreciate everybody's time and great questions. If you have any other questions, by all means, feel free to reach out to us at Crank Software. You can contact support@cranksoftware.com. I believe my contact information might be available in the slides as well. And more than happy to answer your questions and get you up and running. And, you know, Scott, if you have any remarks, or Shelby and Ethan, I'll send this one back to you.
Yeah, just going to remind everybody again about support.cranksoftware.com. You know, a great resource for finding some of the questions that maybe we didn't get to today, or maybe some questions that may pop up later on today or later on in the week as you think about it a little bit more. Definitely give it a chance to take a look there. Also, for anybody that didn't have a chance to get your questions, if you want to, feel free to reach out to me at snyder@cranksoftware.com. You know, whether it was asking for some additional elements to be done within the demo of how do you interchange this, feel free to reach out to myself or Nick or someone on the sales team, and we can set up another session with you to really kind of walk you through it if you like.
Great. Well, thanks everyone again. And like I said, this recording and the presentation material will also be up on our NXP web in the next few days. So do keep a lookout for that. But with that said, we'll close out this webinar. Thank you.
Thank you.
Thank you.